Hello, wonderful 7th graders of Ed Wilkie Middle School.
Miss Rose, you sound so different today.
I know, right?
She's changed. Oh, no, that's
I should have been like, hello, 7th graders. No, guys. Welcome back. Today we're talking about similar figures. Obviously, right?
You know, my husband heard my intro one time and was like, what do you do that for?
Oh, your poor husband. Oh, my
I know,
goodness.
my poor husband.
The learning target for today is that we will identify whether or not shapes are similar by finding a common ratio for corresponding side lengths.
Wait, are we pulling in ratios now?
I think that's what I just read.
And now ratios? What is a ratio?
Comparison of two...
A fraction.
Comparison of two quantities.
A over B.
Or it could be
It's a
2B.
fraction. Yeah. We're pulling in the fractions and the ratios and the proportions. Yay! Did you just do jazz fingers? Congruent. It means it has the exact same size, exact same shape.
Same shape.
Is that same shape?
Too many S's in there. Same size and shape.
Means the same.
Same.
Means the same. Congruent is the same.
Yes. This little squiggly line, when you see one of them, it means it's similar to. So that's the symbol for similarity. So if I have triangle, this just means triangle ABC, which stands for this triangle here, is similar to triangle DEF, which refers to this triangle. That's all that little squiggly line means. It's similar to. So if these are similar, you're going to notice the ratio.
I just want to make sure that they know this. Yeah.
The ratio is going to be proportional. So when I've got my A over B is 6 and my D over E is 12, it had a scale factor of 2.
Because we gotta talk about kind of what scale factor is. Scale factor either when you're blowing it up bigger or shrinking it down smaller.
Yes.
So you can clearly see A and B, it corresponds to side D and E over here. Going from 6 to 12, obviously you multiply by 2. So that's the scale factors too.
So this states like A, B, and D, E here are the similar ones, and it's the 6 over 12. So.
I mean, if you look at the ratios of the other sides.
Yeah.
So if you look at AC, can you write AC over here for me?
AC.
AC over DF.
DF.
That's 3 over 6.
That's an F, I promise.
So if you simplify that, that simplifies to 1/2, and this simplifies to 1/2. Therefore, they are proportional figures.
So we're getting 1/2 because if we were to look at this and go scale down, you would have to cut 12 in half.
Yeah.
So that's where.
So that's kind of where those come from, and this is the ratio of line AB to line DE. So two figures are similar if they have to have all three of these things. They are the same shape. They cannot be similar if they're different shapes.
That doesn't make
Right.
sense.
They could be a different size.
Yeah. So the corresponding angles are congruent. So the angles are congruent. We just talked about congruent. It means
The same.
The same. So my angles are congruent. So if you look at these rectangles, the angles are all 90 degrees. Okay, so all the angles are congruent.
So same thing with this one that we just finished doing. That means that angle A is congruent to angle D. Angle C is congruent to angle C. I'm sorry, F. And then angle B is congruent. You just have to do 3 this time to E. Just showing you that that's... So if we hadn't given you any measurements,
Yeah.
it could have been a possibility for similar figures just because the angles are all congruent.
So if you ever see things and they've got these little lines in it like that, that just means that the angles are, that's the congruent angle on the other similar figure.
Yeah, we're not just decorating the triangle.
No.
Oh, goodness. No.
So the corresponding angles are congruent, and lastly, it also has to have proportional corresponding sides. So the sides that correspond with each other, so BC, has to be proportional to RS.
And basically what that means is that this ratio is equivalent to this ratio is equivalent to this ratio is equivalent to this ratio. That's all that
Exactly.
means.
Just like we showed you with this triangle as well. That was the ratios.
And because
the corresponding
they were both
sides.
one half, they
We know that
have
they're-
proportional corresponding sides. And corresponding, you want to talk about what corresponding is?
Yeah, we can talk about what corresponding is.
Corresponding is the exact same location. So this
It's
one
important.
is on, this one's on the left hand side. This one's on the left. They correspond to each other.
Yes.
Okay, these are the tops. They
Right. So
correspond to each other.
CD,
you guys-
what would that go with?
CD would go with
ST.
ST.
You do have to be careful though. Sometimes the shapes are flipped and you have to find which one corresponds with which one by using the angles. So like in this one, it happens to be that they are in the right shape, and we will see this coming up in our video as well. So,
Here's a little example of what we're
Just
talking
real
about.
quick right here. So even though I'm not going to say the top corresponds to the top, that obviously doesn't mean the same thing. This one's the longest one.
It's gonna
Therefore, it's going to
correspond
correspond with
with
the
the
longest
longer
one
one.
over there. Okay, so that I just wanted to show you a real quick
yes.
example of what
And we
that
have
is.
another one coming up.
Awesome, perfect.
Yeah. Ha! There it is. Look at that. Are these triangles similar?
No, because they're not facing the same way.
No, because we just talked about it. The corresponding shapes can flip. So, which angles correspond with each other? I know I didn't put angle
The
ones,
right
but
angles.
the right angles correspond. So that would mean I'd have to like flip one of them over.
Yeah, I don't
Right.
know how you're going to teach it, but I was just going to say I always identify the longest side,
Yeah,
the
that
shortest
works.
side, and the middle side. That's how I know they correspond with each other.
Definitely.
I always think about the hypotenuse, but they don't know what the hypotenuse is yet. So in a
Yeah,
right
I
triangle.
I always say the longest side. So
Yeah.
you identify the longest one here.
So
and
the-
I'm
yeah.
real weird. Like I'll put a square around the longest side, a circle around the shortest side, and then a triangle around the medium side, and it works. So
So we've got,
That's
what is
cool.
the longest side then?
10 and 5.
10 and 5. So we're looking at 10 and 5. So we're going to create the ratio. And we've got 5 over 10. What does that simplify down to?
1/2.
So equals 1/2. So my ratio of my longest sides is 1/2. What about the next longest side?
4 and 8
4 and 8. So I put 4 over 8. What does it simplify down to?
also equals 1/2.
And I'm going to double check the last one just to make sure it didn't go a little wonky on me. What's the
And
last
that's
side?
possible.
3
It
and
is
Very
6.
possible.
It is very possible that last one could go wonky on you. Always check them all, which simplifies down to 1/2
1/2.
again. So are these triangles similar?
Well,
did
they have? I was just gonna say they have.
they have the same shape?
Yes.
shape.
Yes. Corresponding angles. This one corresponds with this one. I can throw this in here for you. And,
Nope, right down there. Yep.
And
2.
Now that I have a question, a genuine question. We did not have that identified for them. Is it? It's not always going to be.
it's not always going to be identified.
I was gonna say I would have done some kind of markings like this to
let you guys-
identify what angle matched with what angle over there.
And just so you know, this is actually pulled straight out of your textbook. The book did not identify
And I was
it,
gonna say, it's
and you
not-
won't always see it
not
identified.
always-
you don't always need it either.
No, you don't.
Right.
Because there's no way you can form a right triangle
Without.
with these numbers that's not going to have the same degrees. Like
Yeah.
45, 45.
Yeah,
Right.
It's only going to work.
So
that way.
let's look at our last one, the proportional corresponding sides. Did it have proportional
Yes.
corresponding
We
sides?
checked all 3.
So we are good.
Yep. Pen wasn't
So find the missing value. If we've got, this tells me triangle ABC is similar to triangle DEF. Do I need to find out if it's similar?
Yes. No.
No,
it's
No,
telling
it's
you.
telling you.
It states it for me. So I have to find out which side is similar. And guys, let me tell you something. It's actually telling me the corresponding sides. When
It
it tells
is.
me triangle ABC and DEF, that means AB corresponds with DE. And BC corresponds with EF. So when you see those in that order, they put those in order for a reason. So let's look. AB to DE.
So 3
Or
over
sorry,
12.
Yeah, DE. So 3 over 12.
So we're looking at this one and this one.
So what does 3 over 12 simplify to?
1/4.
Okay, so it's 1/4. Now, do I have to do the other one? 'Cause-
Yes, we have to.
Well, it's similar. We already
told us
know.
it was similar.
So should I just set up a proportion?
Yes,
You can
using-
at this
just make
point.
sure you're using the EF. EF corresponds to BC, so EF and BC.
Yeah. So can't I do?
We should probably do AB to DF.
So we've
and
done
then-
that 3 over
Okay.
12 or 1/4. I'm gonna do the
Okay, and
1/4.
then what? BC
Oh,
to
can I-
EF.
5 over X.
Can't I just do 3
Yes.
times 4?
You can. Well, that's what.
You mean 5 times
yeah.
4?
No.
No, times
3.
three.
Just to show, 3 times 4 is 12, therefore 5 times 4 is
20.
20. Done.
So we can do that.
So you
it
can
doesn't-
visually see the scale factor right there.
Right.
And
that's-
if you see that, great. If you didn't and had to set up the proportion, am I still going to get the same answer?
Yes.
If I cross
20
multiply,
equals X.
20 equals X.
I usually teach it this way because I don't have to draw that out. The only time I do that,
I want them to be able to solve it by using a proportion if they need to, though.
I teach both so that if they can't see it instantly.
When I taught proportions. And now I'm teaching similar figures, so I want them to see the scale factor because when they see similar figures, they have to know what scale factor is and they have to be able to identify it. When you do it this way, you don't identify it.
That's true.
See what I'm saying? So here, I like them to identify the scale factor because that's what similar figures is all about, is scale factor.
That's why we're all doing this together, so that they get all the information.
Yeah, no kidding.
Okay, well, I think we are out for the day, right?
Yes, ma'am.
Okay.
Bye, kids.
Bye, guys.